Hello students, welcome to Marine Engineering Tutorials. I'm Atul Kumar Gupta and I'm back with a new tutorial. Presently we are studying marine auxiliary systems. In this lecture we will first learn about the specific features of centrifugal pumps. Next we will study the working principle of centrifugal pump. Then we will learn about the layout of centrifugal pump. After that, we will study the construction of single stage, single entry, vertical centrifugal pump. Next, we will explore the advantages of double entry pumps over single entry pumps. Then we will differentiate between the NPSH requirement of single and double entry pumps. Finally, we will study the construction and operation of two-stage vertical centrifugal pump. Let us now go through each of these topics one by one in the following slides. Specific features of centrifugal pumps. Category of the pump. Centrifugal pumps fall under the category of rotodynamic pumps. Being rotodynamic in nature, centrifugal pumps cannot handle vapors, therefore, the pump casing must be filled with liquid before operation. Specific uses. Centrifugal pumps are used to handle low viscosity liquids. Liquids handled on ships through these pumps may include water, petroleum products, and chemicals. Characteristics of centrifugal pumps. Centrifugal pumps provide constant flow rate and discharge pressure with respect to time. Centrifugal pump provides a constant head or pressure for a certain system because the impeller diameter is fixed and motors usually operate at constant speed. Since the maximum pressure developed by the centrifugal pump is limited, it does not require a relief valve and is usually started with the delivery valve closed to limit the starting torque and current. Drawbacks of centrifugal pumps. As centrifugal pumps are unable to handle vapors, they must be equipped with a priming arrangement to remove air or vapors from the suction side when expected to draw liquid from a level below the pump, especially when the liquid is volatile in nature with high vapor pressure. This problem can be eliminated if the pump is submerged in the liquid. Working principle of centrifugal pump. This sketch shows a schematic diagram of a centrifugal pump explaining its working principle. The centrifugal pump consists of an impeller mounted on a shaft driven by the prime mover, which can be an electric motor, a hydraulic motor, a diesel engine, or a steam turbine. The impeller has a number of vanes which displace the liquid trapped between them, thereby imparting kinetic energy to the liquid. Liquid enters the pump through the center or eye of the impeller and flows gradually outwards between the vanes, where its velocity is increased by the impeller's rotation. Once the liquid reaches the eye pumping begins and continues as long as the required net positive suction head is available. As the liquid is discharged, a partial vacuum is created at the impeller eye, inducing more liquid to flow in and fill the space left by the outgoing liquid. A diffuser or volume casing is used to convert most of the kinetic energy imparted to the liquid into pressure energy. To restrict internal leakage from high pressure side to low pressure side, a minimum clearance between the impeller and casing is maintained by wear rings on both the low and high pressure sides, which improves pump efficiency. To balance the thrust caused by the pressure difference on either side, equalizing holes are provided at the impeller eye. These allow the liquid leaking to the back side to return to the inlet side, thereby balancing the thrust. The liquid is finally discharged from the pump delivery connection. General layout of centrifugal pump. This sketch shows the general layout of a centrifugal pump, which may be mounted vertically or horizontally. Vertical arrangement is more common on ships as it results in space saving. It consists of an impeller mounted on the shaft, which is driven by a prime mover. The impeller is secured to the shaft with a key and lock nut. The impeller rotates inside a casing that provides passages for liquid inlet and discharge. Upper end of the shaft is supported by motor bearing, whereas the middle part is supported by line bearing, which maintains the required clearance between the rotating impeller and the stationary casing. Wear rings maintain the required clearance between rotating impeller and stationary casing and restrict the leakage of liquid from high pressure side to low pressure side. A number of axial holes are drilled in the impeller to equalize the pressure on back and front side of the impeller to balance the thrust. The drive end of the shaft is fitted with a gland to prevent liquid leakage. The sealing arrangement provided either by gland packing or a mechanical seal requires a cooling liquid for lubrication and heat dissipation, which is supplied from the pump's delivery site. The pump shaft is attached to the motor shaft with a flexible coupling, which can absorb some amount of misalignment between the two shafts. Single stage, single entry, vertical centrifugal pump. This sketch shows the construction of a single stage, single entry, vertical centrifugal pump, which is a common arrangement on ships as it saves the space. Pump frame is built together with pump foundation and casing, equipped with suction and delivery connections. Top cover consists of a line bearing for supporting the shaft where the liquid being handled provides cooling and lubrication. Pump shaft passes through the top cover and is attached to the impeller with the help of a key and nut. Replaceable wear rings are fitted in pump casing and top cover to maintain the required clearance and restrict internal leakage between stationary and rotary parts from high to low pressure sites. Gland restricts the leakage of liquid around the pump shaft, which is stopped by packing rings. For cooling and lubrication of gland, liquid from the high pressure side is supplied through a small connection. Most of this liquid returns back to the suction side, although a part of it is allowed to leak out. A motor pedestal is attached to the pump casing, which houses the electric motor on its top. This arrangement simplifies the alignment between pump and motor shaft. An intermediate shaft is used to connect the pump and motor shafts through flexible coupling. This arrangement allows removal of the pump rotor without removal of the electric motor. Single and double entry pumps. This sketch shows minute details for the attachment of an impeller to its shaft and compares a double entry pump with single entry, which is used where large volume of liquid is required to be handled, as in case of cargo oil pumps on conventional oil tankers. In a double entry centrifugal pump, the incoming liquid enters the impeller from both sides and then flows centrally into the volute casing for discharge. This arrangement is equivalent to having two pumps mounted side by side on the same shaft and operating in parallel. The shaft has a step on the free end to fix the end position of impeller. The impeller is held onto the shaft with the help of a key and secured in position with a nut. The impeller rotates in the casing and the wear rings fixed to the casing maintain a small clearance with the impeller to minimize the leakage of high pressure liquid to low pressure site. Impeller of single entry pump is provided with a number of equalizing holes which divert the leakage of high pressure liquid behind the impeller to the suction side for balancing the thrust. Equalizing holes are not required in double entry impeller as inlet pressure acts on both sides. The incoming liquid enters the double impeller from both the sides and passes centrally into the volute casing for the discharge. Net positive suction head requirement. The sketch shows the relationship between the pump's net positive suction head requirement on the ordinate and flow for single and double entry pumps on the abscissa. The curves show that the net positive suction head requirement increases gradually with flow up to the design point, after which the rise becomes very steep. It can also be observed that a double entry pump requires lower net positive suction head in comparison to single entry pump, which is a unique advantage in poor suction condition. From these curves, it can be concluded that when NPSH is low, it is preferable to operate two or more pumps in parallel at lower capacity rather than operating a single pump at higher capacity by reducing RPM or throttling the discharge. This consideration is particularly important during cargo discharge operations on conventional oil tankers when the cargo tank level is low and the pump is prone to suction loss. For this reason, cargo pumps are provided with a double entry arrangement. A pump should never be operated beyond its design point, otherwise, it will suffer from cavitation. Two-stage centrifugal pump. The sketch shows a two-stage centrifugal pump which is usually equipped on board as bilge, ballast, fire and general service pump. It also carries an attached vacuum pump for priming when used for bilge and ballast service. The pump consists of two impellers which usually work in series such that discharge of first impeller goes to the suction of the second with the purpose to increase the discharge pressure progressively. Occasionally, these pumps are equipped with a changeover cock to use the two impellers in parallel when high capacity is desired. In series mode, first stage impeller receives liquid from pump suction located above and delivers to the second stage. The second stage then delivers through the pump delivery from the bottom connection. In parallel mode, both impellers draw the liquid combinedly from the pump section and deliver combinedly to the pump's delivery. Each impeller forms the stage and these are separated by a stage ring between the discharge of the two impellers. They have the similar function as that of the mouth rings, which are fixed in the pump casing on the suction sides. To facilitate assembly and disassembly of pump, the casing is vertically split in two halves. Usually, the rotor is independently supported by two bearings. Although in some pumps, load of the upper bearing is taken by electric motor as shown in this sketch, and a water lubricated graphite bearing supports the rotor in correct position. Gland is equipped on the low pressure side, that is the first stage suction, to restrict the leakage of liquid around the shaft. When the shaft is supported by two bearings, gland is provided on either side. Liquid for the gland cooling is supplied from the first stage discharge. Cooling and lubrication to the bottom bearing is maintained by circulation of liquid from the first stage delivery to first stage suction. Usually, the thrust produced by the pump is balanced by providing the suction of both impellers on opposite sides, and such rotors are supported by motor and bottom bearing as shown in this sketch. When thrust is imbalanced, the rotor is supported by two ball bearings which can absorb thrust and prevent the transmission to the motor bearing. As these bearings are grease lubricated, they do not require any circulation of cooling liquid as in this case. Multi-stage single entry centrifugal pumps are used for high pressure application such as boiler feed pump, fire pump for erector drive and deep well cargo pumping, etc. Motor is fitted on the pedestal and connected to the pump with a flexible coupling. A friction clutch is provided for the operation of vacuum pump to prime the main pump. This completes our study about working principle and the layout of centrifugal pump, construction and operation of single and two-stage vertical centrifugal pumps, and advantages of double entry pumps over single entry pump, especially with respect to net positive suction head. This book has been written by me and covers all the topics as per the Indian Maritime University syllabus. It explains key concepts using simple illustrations. The book also includes answers to all questions that have appeared in examinations conducted by Indian Maritime University. I am sure that the book will help students prepare effectively for exams and also support them in working safely with marine auxiliary systems. I hope you enjoyed the lecture. Feel free to share your feedback in the comment section. If you found the tutorial helpful, consider sharing it with your friends. Subscribe to the channel to stay updated with the upcoming tutorials. I will be back soon with a new lecture. Thank you for watching till the end.